We have booster ignition and liftoff of Columbia, reaching new heights for women X-ray astronomy.
The main thing that Chandra does is take these superb, sharp images.
Nothing as beautiful as Chandra sailing off on its way to work.
A supernova is the explosive death of a star. As one of the most energetic events in the universe, a supernova may temporarily outshine the rest of the galaxy in which it resides. But what are supernovas? Every 50 years or so, a massive star in our galaxy blows itself apart in what astronomers call a supernova. Supernovas are some of the most violent events in the universe. The force of the explosion generates an intense flash of radiation, as well as shock waves analogous to sonic booms. These supernovae are often best seen through X-ray telescopes like Chandra. Dr. Patrick Slane of the Chandra X-ray Center talks about supernovas in our own galaxy.
In our own galaxy, these types of supernova explosions occur every 50 years or so. The explosions pound the nuclei of atoms together so violently that they build up all the heavier elements of the periodic table. These are flung out into space where eventually they mix with other interstellar gas and form new stars and planetary systems enriched with these heavy elements. Although our galaxy seems to be in somewhat of a drought for supernova explosions, with the last one being observed in 1604, we see the remnants of these explosions all over the place. The outgoing blast wave from the explosion sweeps up the interstellar gas and heats it to temperatures so high that they glow in X-rays. They can be 40 or 50 light years across, and for the youngest ones, we can actually still see them expanding.
Pat Slane explains how one kind of supernova, called Type 1A, works.
Many stars are formed in binary systems. After one star in the system evolves into a white dwarf, it's possible for the companion star to approach the end of its life, in which the hot interior causes the outer layers to expand. If they expand enough, some of the gas can fall over onto the white dwarf. This transfer of matter onto the dense white dwarf can eventually increase its central temperature enough to detonate the entire compact star in what's called a Type 1A supernova explosion. Here, the entire white dwarf star is obliterated. This type of supernova always produces about the same brightness, unlike supernova explosions of massive stars, which can vary a lot depending upon the mass of the star. These Type 1A explosions can be seen in other galaxies out to incredible distances. In fact, they provided the first evidence that the most distant objects are moving away from us more rapidly than expected, the result of dark energy accelerating the expansion of the universe.
X-ray telescopes, particularly Chandra, are very important tools for astronomers to study supernovas. The supernova explosion is incredibly energetic and can heat any gas that surrounds it to millions of degrees. The debris field and high-energy particles within it are what astronomers refer to as a supernova remnant. Such remnants are known to produce intense X-ray radiation that can last for thousands of years. Pat Slane explains how Chandra's images are used to analyze the debris field and reconstruct the star's explosion.
Because the gas in supernova remnants is so hot, it radiates in X-rays. By measuring the spectrum of the X-rays, that is, the energies of the different X-rays that come from the remnant, we can tell how hot the gas is and what it's composed of. This lets us identify the heavy elements that were produced in the star and its explosion, and compare these with our theoretical models of how these explosions occur.
Scientists think that supernovas can trigger star formation and probably led to the formation of our very own solar system some 5 billion years ago. This supernova also likely seeded the cloud with elements like carbon, nitrogen, and oxygen that eventually went into the sun, planets, and ultimately us. These elements are manufactured deep in the interior of massive stars and would, for the most part, remain there if not for the cataclysmic supernova explosions. For these reasons that are very close to home, and to others ranging to the quest to understand the history of the universe, Chandra will continue to study these fascinating objects we call supernovas. For more information about the Chandra X-ray Observatory, visit our website at chandra.harvard.edu.
This was a production of the Chandra X-ray Center, Cambridge, Massachusetts. NASA's Marshall Space Flight Center manages the Chandra program. The Smithsonian Astrophysical Observatory controls science and flight operations from the Chandra X-ray Center.